Hello, let us look at number 2 from year 2010, Form B. Alright, so let's look at number 2 first here. We have the function g which is defined for x is greater than 0 with these pieces of information. Now find all values of x from interval from x as x goes from 0.12 to 1, at which the graph has a horizontal tangent line. Now that means we need in order for us to do A, we need to set g prime of x is equal to 0. That's horizontal tangent line. To do that, we're going to put the expression into the calculator here. So we have sine and x plus 1 over x. Now I just want to check the mode is in the radian. Okay. There it goes. Now, so that's what we have for the first derivative. Alright, then, since our domain has to be 0.12 to 1, so I'm going to just set the window as maybe 0.11, a little bit before, and 1.1, a little bit after. And once again, we're going to go for zoom fit, 0. Then obviously, we can see two locations over here where we have the g prime to be equal to 0. So let's try to find what those 2 points are. So we're going to find that 0, so right here, number 2. Left bound seems to be way before right over here, so I'm going to say, oh, or I can just move it over. You know what? Since I know the value around there, so I'm going to put it as 0.12. How about that? That would be my lower bound. Right over there. Okay. Right bound, I'm just going to move it over a bit further. Okay. There it goes. And then guess. And that was one value right over here. 0.163. Now, how about the second value? Second value, we're going to do 0 once again. Left bound, I'm just going to call it this way, a little bit after. Right bound, obviously, I'm just going to go for 0.6. Then it should give us another value right over here. Then we realize and the values will be equal to, x has to be equal to 0.359 or 0.163. Those are the two values. Find all values of x. Okay. Now let's look at B. What interval, if any, the graph of g is concave down? Concave down basically means g double prime has to be less than 0. Now how are we going to get that? That we need to plug in the second derivative. So let's try to do that then. Y equals, and I'm just going to turn off the first one, but not erasing it. And here we have 1 minus 1 over x squared. Alright, that's the first portion. Times cosine of x plus 1 over x. Alright, and then we need to have the same interval. And we're just going to go for zoom fit, 0. So it has to be negative, then this seems to be the one section, and right over here it's kind of hard to see. But let us try to figure this portion out first. Now, to see things a bit clearer, I'm just going to make it into regular line. Alright, second calc. We're looking for a 0 right over here, 2. Left bound, why don't I call it as 0.12? And then right bound has to be a little bit about past that. Okay, there it goes. Yes. Aha, so there's 1 point right over there. 0.129. Starts from there. We're going to go all the way up to here. Let's try to look into that. Second trace, number 2 once again. Left bound will be that, and right bound has to pass it. Okay. Alright, I believe we passed it. So that's the second value. That means from here to here. So one of our answer is when x is less than 0.223 but greater than 0.129 approximately. So that's one option, but we don't really clearly know what's happening over there. So what we like to do is maybe let's zoom in a little bit. But what we're gonna be doing is making the window a little bit closer. So how about this one? What we really want to figure out is this one has to be, instead of that, let's call it maybe -5, and then I'm just gonna call this one as 5, and then graph it and see what happens. Still here. It's kind of hard to tell, so I'm just gonna not zoom, set the window as -1 to +1. Then we might have to see what's going on around this point a bit better. About around here, it's going to go below, and then the highest point which we can get is 1. So let's see if this point is below or after 1. Let's figure that out. Second calc, 0. Right bound, let's call that as this one. No, actually we gotta do it one more time. Number 2, right bound. Left bound will be that. Right bound. I guess we passed it just now. And that's equal to 1, exactly 1. So since 1 is not included, we don't have to worry about that. That's the only portion where second derivative is negative, which means concave down. Now, number C. The question is, write an equation of the line tangent to the graph at g equals 0.3. Now, how are we going to find out the equation of the line tangent? We'll be needing 3 pieces of information. Tangent line, that means we need the slope, and we need the point, x point and y point. So from here, one thing that we know is x is 0.3, but we still don't know what y value is, nor the slope. Slope is rather easy to find out. We can just use this value. So let us try to find out the slope first. Slope is simply, we're just going to turn on this one, first derivative, and second derivative, we're going to just turn that off for a second. Now, and we're going to zoom, fit, to figure out what's going on. Alright, and then let us second calc. Let us find out the value, number 1. That's right. X has to be 0.3. This will get us the slope. Alright, here. Slope has to be -0.472. Alright, how about the y value? Y value, we can actually figure them out quite easily. If you get the integral, we're looking at the values from, I guess, 1. And then another value that we are looking at is 0.3. So in fact, 0.3 to 1 for g of x dx would have given us the value of g of 1 minus g of 0.3. G of 1 we already know, which was equal to 2. And this integral we can evaluate. Oops, I forgot the prime here. this expression we can evaluate quite quickly. That means we should be able to figure out what this one is soon after. So let us try to go back here and take the integral. Second calc, number 7. Lower limit will be 0.3. Upper limit will be 1. So there it goes. So that's the value here. That means we get 0.454 is equal to 2 minus g of 0.3. Then what is g of 0.3? Will be equal to 2 minus 0.454. So here we have 2 minus 0.454. That's what we end up getting. So here is equal to 1.546. Now, then using this value, we can plug that into here, 1.546. Then, I believe we have all the necessary pieces of information now. Then y minus 1.546 has to be equal to the slope, which was negative 0.472 times x minus 0.3. All right, that's it. See you later. Bye-bye.